All right, hello everyone. Welcome to Next. Thanks for coming out. My name is Brett McGowan. I'm a developer advocate on the Google Cloud platform, focusing on all things serverless. I'm super excited to be joined today by John Hurd, CTO of Smart Parking. You're going to hear a little bit about Smart Parking later. They are doing some really interesting industrial-grade IoT and serverless around smart cities and parking that I think you'll find super, super interesting. So if you want to follow me on Twitter, I'm at BrettMCG, and you can ask me all of your Google Cloud serverless questions. But as we get started, I want to talk a little bit about what is the philosophy or what are the principles of serverless. There's no official sort of community definition of what it means to be serverless, but these are the three tenets that I like to think of. So serverless means that there's invisible infrastructure. You're running your web server, or you're running your compute code or some query, and kind of all the plumbing underneath it is abstracted away from you. So things like networking and operating system updates, attaching hard drives, patching dependent libraries. These are all sort of taken care of you, so you just worry about your code. Scaling. It's part of infrastructure. You scale up, but also you scale down. So the idea is if you're not actually running a query or doing some compute, you don't pay anything. So this kind of encompasses a lot of pieces of serverless, and generally I consider it to be two sort of types of serverless. There's what a lot of people think of, compute. So these are typically these little functions, these functions as a service that respond when some event happens in the cloud, right? A file gets uploaded and a function runs. So these compute tools in a serverless perspective are abstracting away the infrastructure that's running your application. So the actual plumbing underneath it, right? The virtual machines, the operating system, and so forth. But there's a whole other category of serverless, these so-called backend as a service. And the idea with backend as a service, it's not abstracting the infrastructure of your application, but actual components of your application. So things that make logical, cohesive sense in your application, things like authentication, things like databases. So the classic example that I always use is email. So if you really wanted to set up your own cluster of SMTP and POP servers and work with ISPs to get whitelisted so all your email doesn't get marked as spam, like sure, you can do that. But sending email is probably not the most important thing that you're doing as a project or as an organization. So sign up for something like SendGrid or Mailgun and just outsource it, right? You just consume it as an API, you send them the data, and they take care of all of that. And there's a whole suite of these kinds of backend as a service. So things like databases, texting, payment, and so forth. And these aren't all necessarily Google Cloud ones, but we actually have a whole bunch. So I'm not going to dive into all of these, but this is just a slide to give you a sense that we have these databases, machine learning, and data processing serverless tools. So these are all things that spring to life when they're needed. They do some execution, and then they go to sleep when they're done. And they scale up and down very tightly with your actual usage. So let's dig into a little bit about, so the topic of this is building serverless systems. So putting all of these pieces together. So some things to think about as you're building a serverless system. So we're going to play serverless pros and cons. So a pro of serverless, your resources scale from 0 to potentially planet scale. And that's awesome. That's a huge pro. But the con is that you scale from 0 to planet scale. And why is that a problem? Is because if you are touching systems that don't scale up, you can crush them. So if you have some poor little MySQL database that your, say, Cloud Functions are talking to, and they get all of these requests, and they scale up nicely, and they absorb all of this traffic, that's awesome. But then they slam this database, that could be a big problem, right? So it's both a pro and a con. So one thing you can do, which is sort of the purpose of this talk, you could just go all in with serverless. Get a serverless database. That scales up with you. That's nice. Not always practical, especially if you have some sort of legacy or dependent systems. So another thing you can do is have some kind of queue and make sure that you're not exceeding the quota or the connection limit to your database or whatever your dependent system is. And then finally, you can maybe throttle your serverless compute. So you can say, for some tools, you can say don't have more than X number of instances, or don't have number of X amount of connections. You can let your serverless provider take care of that for you. All right, let's play this again. Some serverless pros and cons. Pro, resources scale from 0 to planet scale. Cons, resources scale from 0 to planet scale. Are you sensing a pattern here? So why is it a problem this time? Well, we talked about crushing your dependent systems, but what about crushing your wallet? So the idea is, actually, if you get a ton of traffic, it'll absorb it quite nicely, but you pay for it. And think about, so there's a couple of solutions here. One, and this is my favorite, get a planet scale wallet and pony up. Just pay for it. I love this because my salary comes from Google Cloud Platform, so I would love for y'all to have huge bills so I can go cavorting about the world. But that's not an actual solution, right? We don't really want to do that. So one thing you probably want to do is be really careful and be really aware of what is happening with billing in your application. So we have these programmatic budget notifications that you can set sort of budget thresholds as your project hits them, so something like 20%, 80%, 50%, or whatever. And it actually, using serverless, you can publish to PubSub and have some cloud function that does some action. So here's what the UI looks like. You can say, all right, my budget for the month is $20. And when I hit half of that, send some message to PubSub. And serverlessly, your cloud function will spin up, and you can talk to, say, whatever appropriate Google Cloud Platform API to shut down some virtual machines, to auto your database, or just make someone aware that, hey, something is going on. Maybe it's good. Maybe you actually just genuinely are getting a lot of traffic. Maybe someone is trying to DDoS you. There's a whole lot of reasons why this might happen. So it's really important to not find out at the end of the month that this awesome serverless system you built gracefully scaled up to infinity, and that's how many dollars are waiting in the other end of that bill. So there's a couple of considerations putting together these systems. I'm going to kind of at a high level touch on some of these products, and then we'll talk about how to put them all together. So serverless for apps and compute. So here are kind of the three broad categories, I would say. So we've got App Engine Standard, which is very serverless and has been for a long time in the sense that it scales up and scales down to 0. So the resources go to sleep when you're not actually using them. And you can run your whole app. Think of like your web app, or your entire web app will scale up and scale down. It's really nice. But sort of the con to that is your whole app scales up and down based on whatever the highest traffic piece of your app is. So if you have some piece that never gets used or very rarely gets used, it's going to scale your whole application up and down based on the highest use resource. Cloud Functions, much more granular. So if a function gets executed once a month, it will literally get executed once a month. And if it runs for 300 milliseconds, you pay for 300 milliseconds. So really tightly granular units of compute. And sort of where this comes into play when we talk about building these serverless systems and stitching things together is Cloud Functions respond to events in the cloud. So file upload events, messaging events on PubSub, and we'll take a look at those later. So these are the things that naturally lend themselves to gluing different pieces of the cloud together. And then finally, we have Firebase, which is a whole suite of tools, including a database, particularly if you're building mobile apps, web apps, or you're doing embedded devices in, say, yeah, do C++ SDK if you're doing embedded devices, or Unity if you're doing games. We have SDKs for that. So here's kind of a visual representation of how Cloud Functions can kind of glue these pieces together. So you've got these triggering events: file upload, a message to PubSub, an HTTPS request comes in, and it activates this Cloud Function. And it automatically, we take care of running it and scaling it in response to all these events. And thanks to things like the client libraries, your Cloud Function is automatically authenticated by default to the whole rest of your Google services. So things like talking to BigQuery or doing machine learning. Really nice integration. You don't have to slough around Surface accounts or worry about API keys or anything like that. It's really nicely automatically authenticated. So Firebase, which I started to mention, has a cross-platform suite of tools. It does a ton of stuff. It has things like virtual Android devices for testing in the cloud. It has things like analytics in your mobile app. It has things like showing ads, doing push notifications, a whole bunch of tools for doing mobile and web development. And how these two play together, specifically Cloud Functions and Firebase, is a lot of people, you can build a fully featured app just using Firebase. So something like Firestore, because your client actually talks directly to the database, which is kind of crazy for a lot of people, but it actually works, and it works really well. And we'll see an example of a customer who's doing that in a little bit. But say we're coming along, we're talking to Cloud Firestore. It does this real-time syncing, so it's talking to other clients. It's really, really nice. But we want to kind of extend beyond the capabilities of Firestore. We want to supercharge it with Google Cloud. So that's where Cloud Functions kind of sits in the middle here. And again, it's automatically authenticated to Google Cloud. So you can have it, say, watch a Firestore database for some record that's getting inserted, some changes happening, some delete, and then automatically it will run, and then it can extend into GCP to do things like big data, machine learning, talk to PubSub to integrate with third-party systems. So let's take a quick example of a demo. If we can switch to the first demo laptop. We're going to do this exact here. We're going to have a Cloud Function that's listening to a database that takes some action. So to show you what Firebase looks like, I will show you all of the code that I wrote that runs on the server, which is none. Everything I wrote for this demo actually runs in the client. The client all talks directly to Firebase. So if you want to see the JavaScript, it's just a few lines. I'm going to say listen in Firebase to the root message node. Whenever that value changes, go to title here, and then change the text. Hopefully that shows up. So that's it. This is literally a .html file. There's no backing at all. So I can come in here. And actually, let's pull up a couple of other browsers. I've got Chrome, Firefox, and Opera. Anyone still using Opera? Oh, yeah, it's always one. Oh, two. Wow. Guess this is a big room. Keep the faith, my friends. So here's my database. It's called Raccoon House. It's a long story. I'll tell you later. I just love raccoons, actually. That's the whole story. So it's listening to this message node, right? So whenever this value changes, it's going to automatically change over here in these three other applications. So I'm going to say, hello, Google Cloud, next, and hit enter. So just to explain what happened, this over here on the right, that's Firebase, that's running in the cloud. And then over here, my app on the left is my app with literally just JavaScript. But like I said, Cloud Functions bridges the gap between Firebase and Google Cloud. So let's apply some machine learning. I pre-deployed a Cloud Function that's going to watch not for message, but for message 2. And it's going to take the value that I put in there and apply some machine learning translation. So I'm going to say, hello, all of my friends, and hit enter. And you should see, again, it automatically updated it, but then it also translated it to Spanish. Hola a todos amigos. But of course, we have a lot more than Spanish as part of the Google Translation API. So maybe we'll translate it into Japanese, French, Danish, Greek. And actually, we can do way more than 5, right? So let's translate a whole bunch of these. Because we had a Cloud Function watching this node here, and then adding it automatically to the database. So with just a few lines of code, we can just get these results from the client. All right, let me go back to the slides. All right, so that was computing, so that was functions, that was Firebase, and that was App Engine. So I'm not going to go into too much detail on some of these, but just to kind of know, when we talk about data, I like to think of it in 3 categories. There's data that your application runs on. So think about you have an e-commerce site, and you're doing things like holding a shopping cart for a user, you're handling inventory. These are like active reads and writes to your application. So we have a couple of things there. Firestore, which is a NoSQL database. I'll talk a little bit more about that in a second. We have Bigtable, which is not technically serverless in the sense that it does not scale to 0. It scales down to still very expensive. But it is powerful, and John will talk a little bit about how Smart Parking uses it in their architecture. But then you have reporting, and BigQuery, which you've probably heard a lot about, sort of our serverless reporting tool. So you can query petabytes or terabytes of data using standard SQL. But you don't run your app on BigQuery, right? It's just a reporting database. You dump all of your data into it, and then you can have your data scientists churn through it, your statisticians, and really do interesting reports and visualizations. But you don't like run your app on it. And then data flow, if you need to enrich or transform your data in real time as it comes in, you can actually sometimes get away with that using Cloud Functions for like kind of a lightweight way to do it. But if you need to do real data transformation, then data flow is the way to go. So just to dig in just a little bit into Firestore, so NoSQL database, it's serverless. So again, one of the tenets of serverless is you only pay for what you use. So Firestore, you literally pay per operation on the database. So if you're not doing writes or deletes, or reads, you're not actually interacting with the database actively. It doesn't cost you anything, right, other than sort of the storage that's already in there, which is a really interesting model for a database. You don't have this like persistent cluster that you just have to keep hot and keep replicating. That's all handled behind the scenes, and you only pay when you are actively interacting with it. Has offline support for even for web, so it can kind of cache these, and it's kind of intelligence around fetching actually from the database or fetching from a local copy. So super, super cool. I could do a whole talk on Firestore, but there are tons of them at Next, so definitely check those out. And then yeah, serverless pricing. All right, and then last I'm going to touch into serverless machine learning, and then we're going to see some examples of how people have put all of these together. So on the spectrum of machine learning, from a generic task, like I just want to know if this is a dog or not. So we have a whole suite of machine learning APIs, so like a vision API, a speech API, and these are trained for just general purpose problems. So in this case, I want to know, I don't necessarily want to know, is this a dog? I want to know, is this Miss Potato? This is my sister's dog. When I first put this slide on, it just said potato, and I was like, that seems like the worst machine learning model ever. There's like potato. No, that's her name. Her name is Potato. So Miss Potato. So on one end, there's these pre-trained APIs, and the other is you have these specialized TensorFlow machine learning models that your data scientists have gone through and written. And we do have a serverless tool called Cloud Machine Learning Engine that will scale up your TensorFlow to do training based on huge data sets and have these kind of automatically choose some parameters to see what would train best on. And then it can also scale up and down on prediction, so once you've actually trained. But you still actually have to write machine learning code. And as you saw today, though, we actually have something that sits in the middle. We had a couple of announcements around that for AutoML. So if you missed the announcement or had not heard of AutoML, the idea here is you take a bunch of images, so a bunch of images of potato, not of potatoes, and then you give it to ML Engine, and it will learn to recognize, for example, one particular dog, one particular cat, or whatever makes sense for your business usage. And then you can just talk to it via a client library or an HTTP endpoint. All right, so now let's talk a little bit about how do we put all of these pieces together. What are people doing with that? So in a pragmatic perspective, like how do you actually connect these? So one of the things I think is interesting, serverless architectures tend to be event-driven architectures, which means in a traditional model, I have my monolithic app, and I want to take some action. So I actively make some call to some other endpoint. But then you kind of run into these whole issues. Well, what if that endpoint is down? Now I have to sort of queue up the request. What if there's latency? I also have to have a discussion a lot of times of like, what does this endpoint look like? What kind of data format do you need it in? Well, a lot of times you can just use events as your API. So we as a cloud provider have standardized, like a file gets uploaded, and here's what that looks like. Right here is the fields that you will get. Here is, for example, a timestamp of when the file was modified. Here's the path of where it is in cloud storage. And that can serve as your API in a lot of cases. So I don't actually even have to have a conversation with someone who's working on that file because they know what that's going to look like. It's been predefined as a serverless event by, for example, Google Cloud. And I've actually built a whole bunch of apps where literally I was just, hey, I'm going to give you a file. And that was the last conversation we had because it was all standardized. But you will have plenty of cases where you want to do more complex interaction. You actually need to have data that goes along with that file. So their Cloud Pub Sub is your friend. And I'm not going to go too deep into Cloud Pub Sub, but I think it often gets overlooked as a piece of Google Cloud because it's incredibly powerful and incredibly flexible. And if you don't know what Pub Sub is, it's essentially an asynchronous messaging system. So you talk to it over HTTP or gRPC, and you can just give it arbitrary, let's say, JSON messages, whatever format you want. It's really, really fast and scales really, really high. But as its name implies, Pub Sub, if you're not familiar with it sort of as a model of message delivery, it lets you do things like have multiple subscribers creating subscriptions to a topic. So what that means in practice is if I am, say, a Cloud Function, and I'm doing some computation on a piece of data, and I want to sort of hand it off to the next chain in the architecture, I could just call it directly, But then say, what if I have other things I want to swap in, either in the middle there, or I want them to also respond to that event. So now I kind of have to make this thing aware of what's happening next in the architecture, if that makes sense. What you want to do is just push it to PubSub and have at it, and then whoever wants to subscribe to it, and it could be Cloud Functions. There's a nice integration with Cloud Functions and PubSub. Whoever wants to subscribe to that topic and get that data can pick it up. It could be something in Google Cloud. It could be something off-premise. It speaks HTTP and gRPC, so it integrates really nicely with a lot of third-party systems. So let's take a look at what this looks like. Oh, here's the subscribers. 3 different subscribers can all respond to the same message because they're all subscribed to the same topic. So here's what this might look like in practice. So again, we've got our app. We're just talking to Cloud Firestore. We're happy as can be, but we need to take some kind of action. So say I've added a user, a new employee comes on at my company. So I insert them into the Firestore database under the users document. So Cloud Functions recognizes that, picks it up, and says, aha, I know some other things want to take some. We have a new employee. There's a lot of things that have to happen other than they just get inserted in the database, right? So the Cloud Function just doesn't do anything. It just publishes a JSON message and says, hey, here's the user ID. Here's whatever relevant metadata. It goes to PubSub. And then we have a couple of other systems that are listening to PubSub. So we have maybe a third party, another function on Google Cloud that handles the badging. And so the badging system is just nice integration, Cloud Functions. You just say, hey, listen to this topic. Whenever a message comes in, automatically run. But then maybe we have some other system, some IT help desk system, that doesn't run on Google Cloud. But it does speak HTTP. So we could actually have it listen to that same PubSub topic. So with one message, we can fan out to as many systems as we need. And it turns out to be really, really flexible and dovetails really nicely with this event-based system. So a couple of real-world architectures where we're seeing people put all of these serverless tools to use. So there's one, medical consulting by a company called Clouder. So let me describe it sort of very, very briefly, and then we'll see it in action, actually. So the idea is, you go to the doctor, you have a conversation, they talk to you for a while, and then sometimes they'll take notes as they type, sometimes they wait till the end, and then they type up the notes. But there's a lot of tendency to, there's a lot of work there, right? So what the folks at Clouder did is they came up with a system where it basically will transcribe the doctor's conversation with you. And using the Cloud Speech API, it will transcribe it, put it into text, so you can do processing. You can use the data loss prevention API, DLP API, to actually redact personal or sensitive information, because maybe you don't necessarily want to store personal information as a part of this record, like as a part of this transcription. Maybe that lives in a different database because it's sensitive. So the DLP API can actually extract that, can sort of star it out, can handle images. The DLP API then puts it in cloud storage, which has a trigger for the natural language API to do processing. And do things like what was the sentiment, what were the nouns and the verbs. And once you get to the natural language API, there's a whole world of things that open up. So you could, for example, imagine a situation where you have 2 microphones, one that's near the patient, one that's near the doctor. And you could actually do sort of some mapping. You could say, oh, I saw that the doctor asked this question at this timestamp, and the patient responded at this time. And so you can do some correlation. You could start to develop some really, really powerful data processing and mining techniques to improve healthcare. And so we are actually fortunate enough to have, do you want to come up? So this is can we go back to the demo one laptop? So Clouder is a company based in the Netherlands. So this is a Dutch app. And since I do not speak Dutch, I'm going to have some help. You want to, let's see, can you say, what's a really serious medical situation? I have an itchy knee.
You have an itchy knee? Okay.
Yeah, I don't know what that is in Dutch.
Ik heb last van jeuk aan mijn knie.
I will not repeat that. Not because it was offensive, because I don't speak Dutch. So you can see now it's taking the audio file, uploading it to cloud storage, where again it's going to go through that chain of using the speech API to transcribe it, DLP API to redact personal information, and then it's going to do some analysis. And so we have here results. So if we click that, it actually has, ooh, I don't speak Dutch, but, oh, we missed it. We're missing the transcript.
Anyway, it detected joke.
Yes. So I don't speak Dutch, but I'm guessing that first one, knee, is knee. And then what is juk?
That's itching.
Itching. All right. So it actually was able to identify location, so where in the body was the issue, and then a particular symptom. And then can we pull up the other one so we can see? So this is a previous one, so they actually did the transcription. I'm going to blame the Wi-Fi, because when a demo ever goes wrong on stage, it's probably the Wi-Fi. Cool. Thank you. Yep. Yes. All right. If we go back to the slides. I think speaking Dutch is applause-worthy, because I do not speak it at all. I'm sadly monolingual. So here's another example of production sort of serverless architecture that we've seen. There's a company called Guesswork, and they solve an interesting problem. So they solve the problem of being a recommendation engine for users who have never used a site before in a market where e-commerce is often new, or the site itself is new. So how do you make recommendations when you have no history of purchases, either in sort of your store at all, or for a particular user specifically? So it's an interesting, complicated problem, and they use a mix of machine learning and serverless. Super cool. So part of what they do is they do it on images. So they will look at products across countries and across continents to see, OK, maybe I don't know what this is called in this language, or instead of actually translating the metadata around it, they're like, well, let's just take a picture of it, right? A bowl is here, a bowl is a bowl in China, is a bowl in South Africa, is a bowl in Texas. And so by using the Vision API and some custom machine learning, they can analyze these images. And so they actually can aggregate data across huge amounts of existing e-commerce data sets to actually make intelligent recommendations when they really have no actual history or basis to do it on. And they do it all serverlessly. So the kind of classic example, Black Friday, they went from 1 user essentially to 20 million in 1 day. Thanks to the power of sort of that scaling up and scaling down of serverless, all of these components scaled up with them. So the flow is essentially the users on their mobile app, and they're talking to Firestore. And so this is interesting because they actually replaced, they were using App Engine for their web backend, and Data Store for their data storage. And they replaced both of those. They got rid of App Engine and Data Store and used just Firestore instead. And that's because your client talks directly to Firestore. And it turns out a lot of what the App Engine app was doing was literally just taking data from the client, putting it in the database, getting data from the database, giving it to the client. And in a Firebase Firestore model, when your client can talk directly to the database, and don't worry, it's protected by a bunch of security rules, and there's kind of a whole process around that. But it actually eliminated one of the layers entirely of the architecture. They were able to consolidate it entirely into Firestore. So anyway, the mobile app talks to Firestore, and those database records key off a couple of cloud functions, one of which goes to the Vision API, takes a look at, OK, what is this user looking at? OK, I'm going to extract some labels, and then go and try and find some matching, and then also pump some of that data into BigQuery so they can do some reporting later. And then, of course, going back to the theme of backend as a service, is there some service that is out there that does what you want to do? Don't reinvent the wheel. So they use SendGrid to send the email directly to the users to make those recommendations. And one of the things that they liked about Cloud Functions, so not just that it's scaled, but because Cloud Functions are designed to be sort of single-purpose, little dedicated functions. There's a bunch of them strung together. So they could actually swap those functions out and do like refactoring their code, or they can experiment with new things, do some A/B testing, for example, using PubSub, and say, OK, well, we have a message coming into PubSub, and we have this function that's listening to it now. Well, let's actually spin up some other function that also listens to it and kind of do some A/B testing in parallel. And you never have to take the system down at all. It's all happening live. So super interesting and super cool architecture using all serverless tools. All right, so that is all that I have as far as those. For another even more interesting use case, I am excited to welcome all the way from Auckland, New Zealand. I was fortunate enough to visit these folks a few weeks ago when I was down in New Zealand. The really, really interesting stuff that they're doing. So please welcome John Hurd, CTO of Smart Parking.
Thank you, Brett. It's a real privilege for me and actually some of my colleagues to be here and just tell you and share with you a little bit of our journey into a purely serverless system, which has started to replace our legacy platform. First of all, I'd like to just tell you about smart parking as a company. You probably don't know who we are, because we're sort of one of those little startups that started up down in the south of the world. The technology is developed in Auckland, New Zealand, but we've grown, and we now have operations all around the world. We've been going for 15 years. You're probably aware, most startups, when they become, people become aware of them, you've usually been around for a little while. We have tens of thousands of sensors now installed around the world, and these are dealing with probably one of the things that you hate the most, which is parking. But our mission is to actually reinvent that experience, and part of the strategy that we've taken is using new serverless technology as a way to also reinvent that. So just as a picture, this sort of outlines the solution framework that we actually have today. And this is actually in operation in real-world cities all around, and I'll come on to that in a moment. But first of all, we have a very comprehensive range of solutions that work today, that our customers all around the world are depending upon day in, day out. This is industrial-grade IoT. You'll be familiar with car parking, right? We all do it. It's one of the hassles of our lives. The interesting thing about parking is, first of all, a car can depart and another one can arrive in really, really quickly. So within the second, we have to detect very accurately whether a car has arrived or departed, and also to obviously know that that car is present there or it's not present in that parking space. And the reason that it's really important is that the parking operator tends to issue infringement notices to you, which could go to court. And so being legally enforceable really puts some very strong constraints on the class of IoT. Now, the other thing that we do is we put these sensors into the ground. There's a diagram there of a car sitting over a sensor. So we put them in the ground, which actually is really bad for radio communications. The other thing is the sensor is actually running on a battery, and it has to last for 5 to 10 years in the road, right? Because we can't run power to them. And we don't have, we can't put big batteries. These have to be small batteries. So these are battery powered, they're radio communication. We put these big metal things on top of it, which really sort of creates havoc for the communications, the real-time communications. And so these are the things that we've had to solve. But most excitingly, and this is actually being driven by our customers, is that this is more than just parking. Because as soon as you put those gateways onto the lamp poles around the streets of the city or inside your multi-story car parks, you've started to build an infrastructure for doing smart city functionality, whether it be monitoring garbage cans, air quality, et cetera, et cetera. And so this is actually where we have started to have to head. And so, as I mentioned, we're in cities around the world, and that photograph there is actually of Westminster in London. Westminster City has our sensors all around the streets. And it's actually changed the way their parking operates in the City of London. So, big question, why cloud native? I call it cloud native because what we're actually doing with our system today is there is no operating system, there is no Linux, there is no Windows. We are not using relational databases, for example, as you would traditionally use. And the reason is that we're starting to build very, very live, interactive streaming systems, and that's actually the requirement of our lives. For example, if you're driving along the road and your Google Map guidance, the turn-by-turn, sort of took 20 seconds to sort of tell you when to turn, you'd be up a tree, right? And this is the same for most of the types of solutions and requirements of our modern world. We're requiring that instantaneous, that live delivery of information. The other thing about going completely serverless, or cloud native as I call it, is that it's allowing my engineering team to focus on the real benefits and the real functions that we're trying to achieve to reinvent that parking experience. For example, when you look at your traditional code, and I'll come onto a slide of our existing legacy system, and you'll sort of understand it, and I'm sure many of you are very familiar with the traditional ways of building platforms. it takes a huge amount of effort, and I would estimate it's between 50 to 70% of your coding effort is just gluing things together, gluing an operating system together with your relational database, with the logic that you've built, with the web server, with the communications. With GCP, with Google Cloud Platform going completely serverless, we've actually been able to eliminate a lot of that. The other thing is it redefines a number of the key things that we've had to deal with historically. For example, disaster recovery. When data now has 11 nines availability in the Google Cloud Platform, it makes you think differently about how you store and replicate and manage information, manage your data sets. And by the way, you know, most of the cloud operators, Google included, it's a really dog-eat-dog, cutthroat competitive market on the pricing of storage of data. And so now we actually treat the storage of data as really a non-issue. It's actually the processing of data that is most important. I sort of explain it that also, when you're trying to do new things, just doing the old doing things the old way and hoping for a different outcome is not really the smartest thing to do. And so we took a strategic decision of doing the technology, building our new platform in a new way with new technologies because we wanted different outcomes. And fundamentally, I am absolutely convinced that what we're going to see over the next 3 to 5 years is that all information system processing and building of large-scale platforms like ours is going to be done this way. In fact, the legacy OSs like Windows and Linux and so on will slowly start to become less and less significant for our future. Next question, why Google? Well, it's important to actually think about the philosophies and the drives of the vendor that you're using as to why they're building this technology in a certain way. And Google has this mission, which you all know about organizing the world's information. Now, the world's information is schemaless. There is no defined static set class of data. And this is actually important for all of the modern applications we have today. And in fact, all the technology demands the ability to scale up and scale down and to deliver global scale computing is fundamental to what Google's mission is. And so that was aligned with what our requirements were. As Brett has already outlined, Google has been building and taking from their assets of knowledge this deep and broad range of serverless building blocks that we can actually quickly put together. And then finally, machine learning, which is the way we are going to interact and deliver information in much more fluid and natural and consistent and continuous manners is through machine learning. So Google's machine learning centricity was also significant to us in our decisions there. So let me just quickly go through what we call Smart Cloud, which is our platform for doing this smart parking solution, but also, more importantly, expanding out into smart cities. First of all, we wanted to be able to ingest and send communications to anything. And so having an open IoT framework, which is IoT Core from Google, was a key element in our construction of Smart Cloud. It actually allowed us also to eliminate all the burden of developing that technology, trying to be aligned with standards of the industry, because Google's going to be doing that for us. And it scales up and scales down for the millions and millions of transactions, messages that we deal with today, every single day. So, city scale, global scale processing. Now, the following points on this was about also eliminating and moving, getting different results about what we are trying to achieve and wanting to achieve, was taking the developer out of delivery of dashboards, of being able to do big data type data reporting and analytics, and also business rules. And so we built into Smart Cloud were mechanisms for allowing the end user, the user of the system, to do their own dashboards, to do their own simple big data analytics using BigQuery and Data Studio. And then finally, managed APIs. So this is the sort of application framework and the vision of where we are going. And we're already starting to do a variety of these things. We're certainly doing the data intelligence and analytics. We're deploying broadband off the gateways in the streets so that public can have public broadband. And so we're doing that in one of the cities right now. I mentioned I was going to just show you, this is what, our legacy system looked like. And this is not not every bit of the detail there, but fundamentally this was the architecture of our system. And as you can see, there are lots of moving parts. It is complex. It's actually hard to keep it together and keep it stable, right? Now, and many of you will actually be familiar with this day in, day out, right? And we even had the religion war of the Linux versus Windows in the company as well. And so all these were the fundamentals. And this is what we've moved to. So we've gone completely to using IoT Core as the bottom end, which ingests and egresses messages from devices and sensors through our gateways, which we call smart spots. And then we process those messages coming in using Cloud Functions into PubSub. PubSub is just awesome. It's actually the way that we actually split information into different pools, and we're delivering this information into both Bigtable, into BigQuery, doing processing of it using logic. We're using App Engine, obviously, to run various parts of multi-threaded processing. And then, very importantly, we front-end it with the tools such as Data Studio for data analytics and a variety of other machine learning and such things. And then finally, we've got a whole portfolio of APIs which connect to both our own systems and also external integrations. So I just wanted to, very, very quickly, I know time is running out. Can we go over to demo 2? And I just wanted to quickly show, this is actually Smart Cloud actually in action, and this is the city Hamilton in New Zealand, so live data. And if I tap on it, I can actually see, there's a car that's been overstaying there, and this is just one of the dashboards. And by the way, this is all being front-ended. Behind it is Firebase and Firebase Auth for the authentication, and yeah. So let me show you also. Here's another city, live again. This is Cardiff on the other side of the world, and doing exactly the same things. And I just wanted to also show you the Data Studio data analytics reporting that we have built in. This is just incorporated right into the Smart Cloud system. So this allows data analysts to go and build their own reports. We haven't had to go and create, no developer is required to go and create these reports anymore. And they're rich, with capability that is just fantastic. So we're putting or democratizing the mechanisms of letting our customers do their job. And just as a little additional thing that we're starting to research is using machine learning. And here what we have is we're looking at a small range of parking bays on a street in a city, and this is actually, so the actual, and then using the predicted occupancy of those bays. And we can start to forecast using machine learning, and this is adapting and changing as the dynamics of that site are adjusting. And so this is really exciting because this is going to deliver us new ways of interacting with the user with knowledge about the future, giving them prediction about where the likelihood is of being able to park, etc. So if we can quickly now go back to my slides. So I just wanted to finally summarize, going through, our sort of pathway, our road to cloud native or serverless computing. First of all, APIs are really important. This is actually the way we have defined the architecture, the framework of Smart Cloud. The APIs are essentially the scaffolding and the blueprint. And in fact, if you're a programmer, in that first class, Computer Science 101 programming, it was input, output, and then logic, right? APIs are actually the framework of that input-output. It starts to define the framework. So that was really important for us. The other thing was looking at the data from a streaming perspective. Rather than just putting it into a database and then pulling it out, we needed to actually manage our data in a constant flow stream, right from the device in the street through to the dashboard on somebody's screen or the app in somebody's hand, live and real time. And so this is where we actually are pushing data into Bigtable. Bigtable, as you know, is essentially the same technology that Google Search works on. And what we're doing is we're creating what we call frames, which is a parking event. And so when a car arrives, a new frame is created in Bigtable. And then as new information comes in, such as a payment comes in, or a rule gets triggers something like an overstay event, that frame gets updated. And then when the car departs, that collapses. And meanwhile, while we're doing that, we're pushing those events through PubSub into BigQuery and also into other stores. And what we're developing here is actually a knowledge graph of the information that's going on, which is really enabling us for AI and capabilities. And also, very significant for us, is it's delivering a roadmap of functionality and capability to not just to ourselves to respond to the market needs, but also for our customers as they use it. So we're able to eliminate a lot of the overheads and burdens that we used to have with our legacy system, and we're focusing our energy and being able to allow ourselves and our customers to focus their efforts on things that really make a difference to them. And so I truly believe that we are actually reinventing the experience, and it's really needed, obviously, for parking, right? It sucks. And so one of the things that we're wanting to do is to actually change that experience in a number of ways. And in fact, this is actually the metric by which I actually make judgments about if we're doing something, is it going to reinvent that experience? And this is actually a very important point to me. So just a few things about our little journey with Google so far. We're learning a lot, right? It's not actually a smooth highway with no bumps on the road. We're having to keep learning. But this is actually good, because that means that we're pushing boundaries. We're actually doing something that is actually not just like everybody else. We're actually making a difference. You know, if we're reinventing the experience, this is what you've got to do. You've got to actually experience some pain in it. I mentioned before, focus on data streaming and the data flows. Using Bigtable is still an art. There's a lot to learn, and I see some nods, right? And actually, getting to the last point, you know, we've had great support, engineer to engineer with Google, and it's been actually quite exciting when we pose a question, they go, gee, don't know how to do that, and that's really hard. We can't do that, or so on. And so that's been a really fantastic experience. And we work with other cloud operators, by the way. We're a big consumer of other clouds. And the support we've had, engineer to engineer, from the Google support team is just awesome. Best of my experience so far. So, that was the end of my presentation. And so, just a couple of things. We do have some T-shirts. I know we'll run out of T-shirts, but if you want a T-shirt at the end of the talk, see some of my colleagues at the back of the room. We've also got a white paper which talks about how we do the flow, what we call the temporal parking event processing. And it's not just about parking, it's about anything. Smart Cloud is a very general purpose system. Yeah.
If you don't know what time XYZ time is, no, I'm just kidding. We're not sure. So John will be around. There's an IoT pod. There's a serverless interactive exhibit on the first floor that I'll be hanging out, and a whole bunch of folks from the various product teams and engineers across Google. So please stop by. There's a Vortex cannon. If you don't know what that is, it's going to be pretty cool. And that's it. We'll be around for questions. Thanks.